Hi, this is Mr. Max. So I'm looking at quite a number of complicated expressions where we have to apply the concept that integration or antiderivative is the reverse process of differentiation. So you should also perhaps just do a little bit of revision work on the chain rule. That is what you also perhaps need to look at. Okay, and then also I have written down the constant multiple rule. So this one is, say for example, you have to find the antiderivative of, let's say, 5x cubed with respect to that. So the way you can do this, well, you can pull out that 5 and then you take the antiderivative of x cubed. All right, so that becomes then 5 multiplied by, now you can actually start differentiating or integrating. So that's going to be the x, you add 1 to the power and you divide that by the same plus the constant of integration. So your final answer will be 5 over 4 x raised to the power 4 plus the constant of integration. So this is just something that I'm going to use at a later stage by pulling out our constant multiple, especially when we come across this b part where we now have to find the antiderivative of 3x squared upon 4 minus 2x cubed all squared. All right, so this is one of the things that I want you to quickly revise on, and the chain rule is one of them. So if we look at the very first question, we are supposed to find or to differentiate with respect to x what we have here. So there are many ways you can do this. When I say many, I'm talking about the chain rule. But before we get to that, let's just say that y equals to, okay, this can be written then as 4 minus 2x cube, and it's raised now to power of -1. So this is how this can be written. Okay, so you can also then decide to say let u equals to 4 minus 2x cube. I hope you still remember that. And what I can do here is I can actually find the derivative of du dx. Okay, so in the way you do that, obviously the derivative of constant is 0, so this is going to be minus 6x squared. Take away 1, remember, when you are doing your derivative. Okay, and then something else then, I can go ahead and I can say also let y be u raised to the power of -1, okay, because this whole expression is being replaced by my u. So here I can actually do dy du, and dy du, well, the negative comes in front and then you subtract 1 here. So this is basically the same as negative 1 over then u squared. Okay, so now I have this, so I can actually go ahead and I can do, if I have to find, I can say du dx times dy du should give me dy dx. Okay, it's like your du's cancel. Okay, anyway, we know what du dx is. Du dx is nothing but minus 6x, and we know what dy du is. Well, that was nothing but -1 over u, but our u was nothing but 4 minus 2x cubed. Okay, all squared. Right, so you can actually clean this up, and this is going to give us a negative and a negative. Well, it's just going to give us 6x on top all over 4 minus 2x cubed all raised to the power of 2. All right, so this is the derived function. This is where we have to end with that particular question. All right, so what is that? When you differentiate, okay, you are trying to find what is the original function. So the original function we are looking at is 6x. The function, excuse me, is given to you as 1 all over that. That's the function. So if you are now integrating, when you integrate the derivative, you are actually looking for this function. So it is actually very straightforward if you have a look at that. So we have now to look at two things, and that's where that constant thing comes in. Okay, you see that if you let me just go back to my x here just to correct this, just to have my square there. Okay, just to make sure that we write the correct one. So if you look at what we have derived, we have a 6x squared. Okay, but here the numerator is 3x squared. So there's definitely something that we need to change because they actually nearly look the same. So what we can do is we can say, okay, so this can be written as nothing but the antiderivative. Ooh, it's a little bit out there. The antiderivative of, now you have got a 3 here, okay, so that has to be a 6x. So if that is the case, you can actually look at halving that, okay, because we have a 3x squared, but we got a 6x squared. So in order to get that 6 to be a 3, we need to half that. Okay, so we can actually say a half times what we have here. Let me just write that in a different color. So what we have here is 3x squared over, so but now it's not going to be 3x squared, it's going to be a half over 6x squared over 4 minus 2x cubed, all raised to the power of 2 with respect to dx. Now, this eventually, if you take out the half, right, a half times that is basically going to leave us with the same thing that we have here. But the 6x squared over 4 minus 2x cubed raised to the power of 2, that is the antiderivative of the function that we had to find. Okay, so from this point on forward, that's where I said you have to know the constant multiple rule. So I can actually take out that half. Okay, I can take out that half, and this is where it becomes interesting. And then I have 6x squared over 4 minus 2x power 3 all squared dx. But what is this 6x squared upon 4 minus 2x cubed all squared? What is that? Because that's the derivative. So what is the antiderivative of that? What is the function that once that function has been differentiated, you arrived at that? Well, that function happens to be nothing but the function that we are given, which was 1, which is 1 over 4 minus 2x cubed. So that function is nothing but 1 minus, just make sure we get the correct, 4 minus 2x cubed. So it's 4 minus 2x cubed. So that's what that function is, okay? That's the antiderivative of the derivative. That's what it's going to give you, right? But then we have got a half there that we need to multiply this with, and then you have the constant of integration. You know, your work is basically done here. So you can just maybe write everything, you know, multiplying numerator with numerator. So this can be written as 1 over 2, then in bracket you put 4 minus 2x cubed, all right, and then plus c. You can also leave your answer like that. Okay, so please don't forget that whenever you are dealing with your whenever you're integrating, okay, you need to always put the plus c there. Right, so we are now at the same scenario. So hopefully again you have to apply your chain rule. So this is the function, okay? So this is our function. Just remember that. So when we have to find the derivative, there are many ways you can do that. You can say, okay, let y equals to 2x squared minus 1 all raised to the power of 6. And then you can say dy dx here, right? The way we do this one, you can directly go to that, or you can apply the chain rule, right? So perhaps maybe I should do the chain rule so I can just help you step by step for you to know. So we can say, also in the same vein, we can say let u equals to 2x squared minus 1, the stuff inside, okay? So that's u. And here then, du dx will be, well, it's going to be 4x only, Okay, so hope you know how you're taking away 1 and then you multiply that 2, and the derivative of a constant is 0. Right, so that is du dx. But we can also then say, okay, so in that case, our y can be written as nothing but u raised to the power of 6 from what we have here. And when you do dy du, then it becomes 6u to the power 5. Right? But our u should then be replaced by whatever we have here. So this u will be replaced by that expression. I hope you get that. Okay, so I'll go then straight to dy dx to find the derivative, to differentiate. It has to be the 4x multiplied by, okay, 6u raised to the power 5. Okay, so this basically becomes 4x times 6 times whatever our u is. Our u is 2x squared minus 1. It should be raised to the power 5. In fact, you can clean this up. This is 24x, and then you have got 2x squared minus 1 all raised to the power 5. So this is how we differentiate that, because that should be a little bit straightforward. Okay, so what is the function? Our function is the 2x squared minus 1 all raised to the power of 6. What is the derivative of that function is 24x in bracket 2x squared minus 1 all raised to the power of 5. So we now have to find the antiderivative, but you see now the way it's given to you, all right? The antiderivative, it's nearly identical, but this one has got a 24. Okay, so if that is the case, maybe you can pause the tape and think a bit, right? So what is the antiderivative of this derivative supposed to give us? It's supposed to give us the function when you integrate. Okay, right. So, but there's a little bit of a difference, as you can see, considering how ours is. So this can actually then equal to, okay, just make sure that we have our equal to the antiderivative, or we say integral, the integral of, let's say 1 over 24. I'm just going to put that there, okay? And then I have, because this is what I got when I was integrating that function, it was 24x, and then I had 2x squared minus 1 raised to the power 5. The reason why I put 1 over 24x is because, remember, this should actually sort of give you a 1. So when you multiply this with that, it should give you what we have here. You understand? So I have to take out that 1 there, so to speak, or that 1/24 there. Okay, so I can actually integrate now. Okay, so we can actually pull out before, maybe you can take out the 1/24, then you say you integrate whatever we got in our derivative, which was 24x. So we say 24x, okay, so we have 24x, just excuse that, and then it's 2x squared minus 1 or raised to the power 5 with respect to that. Okay, so but what is this integral giving you? What is the antiderivative? What is the antiderivative of this? It should be the function. What is the function? So let's go back and write that function. Our original function was 2x squared minus 1 all raised to the power of 6. 2x squared minus 1 all raised to the power of 6. Okay, all raised to the power of 6 plus the constant of integration. Okay, right, so you can actually take away the brackets and then your work is done here. So this can therefore become 2x squared minus 1 all raised to the power of 6 all over 24 plus the constant of integration. So this is how this question can be approached. Okay, so you can leave it like the way I did, or you can finish it as I finished it towards the end. Okay, so you have another question here where you can quickly find or differentiate x squared minus 4x plus 5 raised to the power of 6. Obviously, you used to use the chain rule. But what does the chain rule say? Well, the chain rule is dy dx would be the derivative of inside, okay, so first it will have to be 6 times the derivative of inside, which is going to be 2x minus 4, okay, multiplied by the same stuff, x squared minus 4x plus 5, and now this is going to be to the power 5 because we are reducing 1. Okay, so we can clean this up, or we can leave it like that. So this is 6 times 2x minus 4. Obviously that 6 can multiply out, but before I continue, I have to look at what is it that I'm supposed to find. You see, the way my function is, here you have a 2, so 2x squared. So you can actually go ahead and leave that like that. Okay, again, you could easily have used the chain rule if you did not know how to arrive at this. Okay, right? So chain rule still allow you to get the same thing. All right. So just because I did not do it, you can also. I've done it actually, but I have not done let u equals to that. So the way you start, you say, well, y equals to x squared minus 4x plus 5 all raised to the power of 6, and then you can say then u equals to that stuff, x squared minus 4x plus 5, and here you can actually do du dx, and du dx is nothing but 2x minus 4, okay, and then you can also at the same vein say y equals to u raised to the power of 6, and dy du will be 6 u to the power 5, and the only thing that has to happen now is you have to multiply this 2x minus 4, you have to multiply it with that one, and then you replace the value of u with what we have here, and that's basically what you're going to get. So at the end of the day, you can say, okay, so this is going to be dy dx would be equal to du dx, which is the 2x minus 4 should be multiplied by 6, and our u is that whole expression, x squared minus 4x minus 5 all raised to the power 5, and you can clean this up and rewrite it in the form that I had. So it's 6, and then leave 2x minus 4, and then x squared minus 4x minus 5 all raised to the power 5. Okay, either way, that's what you're going to get. So you can see the similarities between what we are now supposed to do. So now at part B, we are now supposed to find we are supposed to integrate or find the antiderivative of 2 in brackets 2x minus 4 x squared minus 4x plus 5 all raised to the power 5 dx. So you can see the similarity, but here you have a 2 and here you have a 6. So what do you think you are supposed to do? There is a constant that you have to consider. Okay, what do you think that constant involves? Just want to make sure. So this is my question 3. Right, so I'll give you like a minute to see, go back to the previous things and see if you can sort of figure out, because you are close to finishing. This part is not that complicated, and also we should also remember that this here is my function. Okay, so I'll have to write, when I am finding the antiderivative of a derivative, that means the antiderivative of a derivative, I am getting my function. My function, I'm going to say f of x, or my function, whatever the function is, plus c. Okay, the antiderivative of the derivative gives you the function, so we know what the function is. Okay, so the antiderivative is going to be that function. So let me just get my notation right. So it will be my function, which is, I'll say y, whatever the function would be, plus c, the y being the function that we have. Good. So we are finding the antiderivative of the derivative. But when we derived, we have a 2 here, other things are still the same. Here we have a 6 here and a 2 here. All right, so we need to be able to do a little something there. Okay. Just clean that up. I hope you have arrived. You have seen what I did. Okay, so where does it leave us? So you can actually now go ahead and say, well, this is going to equal to 1/3, because a third of 6 will give you the 2, right? Then you find interderivative of 2 as it's there, right? The same. Let me just correct that. So we pull out a third of whatever we have. Our function was 6, then it's 2x minus 4, x squared minus 4x minus 5 um, raised to the power 5 dx. Right, so we know what is the function. What is the function here, right? When we are integrating, what is the function? So the function, the y, okay, is this function here that we have, which is x squared, the whole function here, x squared minus 4x plus 5 raised to the power 6. So it's x squared minus 4x. Oh, let's just make sure. X squared minus 4x plus 5. X squared minus 4x plus 5 plus 5. All right, so work there is practically done. I can just remove my square brackets. So it's going to be a third x squared minus 4x plus 5, my function, all right, plus c. A third had to be brought in here because you have to find the antiderivative of 2, blah, 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 blah. But we had a 6, so we need to make sure that we pull out a third, because a third of 6, a third of 6 gives you the 2 that you have here. Okay. Well, I hope it has been a little bit helpful. Please, if you come across this type of questions, just remember there are a few things that you need to be able to revise upon. For example, your chain rule, because at this point, it's very easy for somebody to struggle with or not recall how to derive using the chain rule. And then also basic laws of integration that you need to know, constant multiple rule, okay? And also consider the concept when we are dealing um, with with integration. So you have, for example, the antiderivative of the derivative, okay? That gives you the function. That gives you the function. The function being whatever our y would be. Okay, it gives you the function. Antiderivative of the derivative is giving you the function. Obviously, then you're going to say that function plus the constant of integration. Okay, don't forget to put your plus c. It's very important.